welcome everyone to the next episode of Bones and Stones. Today we've got Joseph Chikumbirike, who's joining us from Kimberley. He's a lecturer at the Saltlaake University, and he's going to chat to us a little bit about his work in Zimbabwe, and specifically Great Zimbabwe. Joseph, thanks very much for joining us. It's great to see you. I think we last saw you at a SAPA last year when we were all in Kimberley. What a great meeting that was. And yeah, thanks for coming on to chat a bit about your work. And maybe you could just begin by talking about what you're up to in Zimbabwe and specifically Great Zim.
Okay, thank you so much, Tim. Good to see you all. And also, I feel excited to be here to be chatting to you or talking to you about the work that I'm doing in Zim. Currently in Zim, I have got two projects. One in Shangani area, like central Zimbabwe, then the Great Zimbabwe one. So I'm going to focus on the one on Great Zimbabwe, which I also did as part of my PhD. The Great Zimbabwe one, I actually focused on, or I'm focusing on the that interaction that that people have or had with the environment, because I'm also using the ethnobotany, the ethnography side of things to give meaning or interpretation to what we get in the archaeological record. So the focus is in the analysis of charcoal, which also is called anthracology, like whereby you get into the archaeological record, you retrieve charcoal either by means of excavations through the trench or maybe by the sieve. Archaeologists, you know what I'm talking about. Then from there, you take them to the lab. But in order to do that, you also need to establish a comparative collection, just like what they do in zoology, archaeozoology, where you will need to be able to identify those, where possible, charcoal materials or to species, genus, species level, where it is possible, with a good comparative collection that is possible, that can be done. So I did that. I did a comparative collection of the trees around Great Zimbabwe and Chikumbirike, like within its vicinity. And then you analyze the charcoal, some of it excavated by Hall 1905, Robinson from like the Hill Complex, but they came from all over, like Great Zimbabwe, the Great Enclosure. Some were coming from under the walls, like when the stonemasons, the conservationists, when they were doing conservation work, they would retrieve this charcoal. So I wanted to like understand the sort of like the paleo environment, ancient environment, from the vegetation perspective. If you remember, like for example, Bannerman, 1982, actually is of the view that Great Zimbabwe was, abandoned due to environmental problems, overexploitation of resources, trees, and stuff. So that was also one of my which drove me to try and see if I can get those kind of evidence from the and identify the trees. What sort of trees were they? Yeah. You mentioned the Brachystegia pisciformis, Gilbernadia, Globiflora, and so on. So in the analysis, I then of course looked at it in the lab, like anatomic. You do microscopic anatomic analysis, the structure of the tree. You are looking at the cells at that level, microscopically taking micrographs, then you compare, then you use those to like identify, to say which like what tree, which type of tree or am I looking at. And then having done that, then what does that tree or tree species tell me, like, about the culture of the people and about the environment? So that's what I did, like paleoecological and paleoecology and the cultural side. So paleoecologically, the environment at Great Zimbabwe did not change much. It's still the miombo kind of trees that you get today, which is there, and which you also find in the archaeological records. And but culturally, you find that there were certain trees that are no longer growing within like the vicinity of Great Zimbabwe, but in the archaeological record they are present. So the question is, where did they go, or how did they come to be at Great Zimbabwe? Edward Matenka, 1996, he did a reconstruction of the Great Enclosure whereby he replaced the lintels, and some of the wood materials, which also I think Hall found, showed that you were dealing with the Colophosperma mopani tree, Spirostachys africana, tambuti, which like you are looking at large distances. So how did that get to be at Great Zimbabwe? Why did people, like the sort of questions you would ask, choose that particular type of materials? So it was probably because of their qualities, construction qualities. Some also, like, they do repel like insects. They are not prone to boring or hauling by insects. So there was that long distance movement of wood, like in excess of maybe 100 kilometers. That is if the environment didn't change, but you hardly see it like within that distance growing in that particular area. So the conclusion that it was coming from a long distance, and also like the chemical medicinal properties. There are certain woods that are considered sacred, right? And so which are not banned or would not be, you wouldn't expect them to be banned, right? Maybe inside the house, unless they are being used for other purposes, such as maybe purposes to do with maybe rituals, religion. So tambuti, I found it in the form of charcoal, but the question would be, people, were they burning it? Yeah. It's, produces poisonous smoke. So what was it? Maybe the burning was, accidental. So that came from the ridge where you have got this, your museum, the museum at Great Zimbabwe. So, yeah, and of course, because I did like an assemblage from Great Zimbabwe sites, and also an assemblage which came from Chikumbirike, which I'm saying it's about like to the west of Great Zimbabwe, about maybe 10 to 15 kilometers, which is an archaeometallurgical site, which is probably is thought to, or postulated to have provided like the metallurgical implements to Great Zimbabwe, considering that Great Zimbabwe was an urban center and there was an industrial like site or area somewhere where they were. So I also analyzed the materials, and again, the charcoal, which was used as fuel, wood or for fuel energy, and again I didn't see a huge difference. It was also again the Miombo type of vegetation, just like in Great Zimbabwe, and the diversity of wood, they were not really like specific, but if you go ethnographically, some research which was done in the Njanja area within Zimbabwe, we find that the ethnographically they are preferring like woods like your Bachia or Bukia africana, right? And but the difference that I noticed between the two sides, Great Zimbabwe and Chikumbirike, is that the woods at Chikumbirike were bent whilst they were still wet. And actually see that the bark was still, and also even the behavior of the cells, the anatomy were like some ruptures because of pressure, because of like, which is usually what is done. They harvest the woods when they are wet, they produce charcoal, then later on use them in the metallurgy or iron smelting or smithing processes. Yeah.
But that's really fascinating work. I have a couple of questions, but I'll hand over to the other guys first. Matt Lott, I see you've got a question.
Yeah, thanks, Joseph. Sorry, Tim took the words out of my mouth. I was going to say this really is fascinating. When it comes to paleo-environmental, paleo-ecological work, this really is exciting stuff, and it's great how you can kind of bring the picture together when looking at these different data sets. But obviously, I know your research focused on charcoal, so I'm going to ask first a question in relation to the charcoal, just in terms of how it's handled at the sieve. I've been on numerous excavations, and when you excavate charcoal out of the ground, how much do you actually need to take as a representative sample? Should you be taking all of the charcoal out of the sieve? Should that charcoal then be packaged in a specific way? I know when dealing with residues, for example, on stone tools, artifacts need to be handled very carefully. So with charcoal, is it the same thing? So how much would be needed? And then just another question in terms of your PhD, focusing on charcoal, did you consider looking at other data sets? And will you consider looking at other environmental data sets moving forward, possibly tree ring data, maybe something to do with phytoliths, from the actual excavations? I just thought that maybe that would be interesting in terms of combining different environmental data sets.
Thank you very much for that question or questions, Matt. Those are in line with what I aspire to be. Actually, to start with, when you get charcoal, except it's also one of the archaeological data set that is also affected by typhonomical conditions. For me, I would really appreciate if you collect everything, because absent presence of certain species in your charcoal assemblage means a lot, either environmentally, culturally, or perhaps taphonomically, how they were processed and during their living time, in the archaeological record, and so on. So it's good to have a larger data set of charcoal, so that at least you will be able to, it informs you more. You are not perhaps confined or limited to just a few. So you have to, it tells you more about what is happening in the environment, or the interaction or the vegetation that was there within the vicinity. And only when it starts to repeat, you are getting the same kind of species in your analysis from that large data set. That's when probably you can stop doing the analysis, like the case that I'm seeing at Wonderwork Cave, right? Where now you are beginning to see the same, the species as beginning to repeat. Then at least it may suggest that you maybe that's all that's coming from the environment. Whether you continue to analyze, you're going to get the same thing. Then coming to the question on other environmental proxy data, consideration was there. Actually, to tell you, when I started my PhD, maybe Matt Karuna can witness, I had a very large, ambitious proposal, where I proposed to look at the palynology, I proposed to look at charcoal, I proposed to look at phytoliths. But at the end of the day, it was just too big to manage within 2-3 years, so I reduced it. But now I'm interested, because I wanted to do some reconstructions, right, to look at even data sets such as the diatoms. There's a site next to Great Zimbabwe, which is known as Chikumbirike, which is the environment more or less like what you get at Great Zimbabwe. And I actually would want to look at to use micro botanical remains such as pollen phytoliths to do what I have termed as paleo-agro ecosystems. Paleo-agro ecosystems, again, that interaction, the sort of crops that they grew, processed within the settlements, and where they grew them. For example, diatoms can tell you that, especially when you are in those river streams, the marshy environments. Okay. So yeah, it's I do have that passion to look into or to include more archaeobotanical remains to speak to the environment within the that context. Yeah.
Kara, I see you've got a question as well. I think we've got a bit more time, so yeah, go for it.
Yeah, thank you very much, Joseph. This is all really fascinating stuff. Just wanted to touch upon how about you go through the identification process with charcoals? Because I imagine you're probably looking at maybe cell structures. So I'm just wondering if you could maybe just briefly explain how do you ID species of plants through charcoal remains?
Thanks, Matt. The way the process is done is that you are looking at the cell structures, and of that particular charcoal piece or fragment that you have, depending on its preservation status, if it's well preserved, you actually expect it to be able to be more like accurate to look at into like three different planes: the cross section, right, or transverse section. Then there's what is called the tangential section, like on the sides. The way you look at the table, this sort of like a race. Then the radial section. So you look at charcoal in three like different directions, so as to be able to be more, you know, accurate to increase your degree of accuracy. And what is happening is you are dealing with the cells. You are looking into the cells, the microscopic anatomy or structure. You are looking at the cells, the cell arrangements, how the cells, if let's say you cut it across that wood or that tree, how are they looking at? So you're looking at the vessels, the xylems, phloem, and you know, there are terms like parenchyma, how the cells are arranged, parenchyma, the fibers themselves. And then when you look at the tangential section and radial section, you are looking at how these cells again are arranged. The way the cells are arranged, they also identify to a particular maybe family, genus, and species. So it's just like it's their DNA, different trees, right, or vegetation, they have got like a pattern in which their cells are arranged. So it is that pattern that one looks at when you are dealing with cells or when you are dealing with charcoal. So, but you are also informed by the modern vegetation. You look into the modern, right? If it's your mopane, right, Colophosperma mopane, you characterize it. This is how it looks like. Then you go and look into the archaeological record and compare. If you see like you get something that is close to that, to be able to say something with you know, confidence, to say this is this type of species that I have in my archaeological record.
No, thanks, Joseph. That's really interesting. And I know I actually have still some questions, but we've run out of time, unfortunately. Thanks for joining us. Thanks for introducing us to this topic. It's fascinating. We haven't actually had a chat about it. So it's great to hear a bit more about how paleobotany works and how you've used it to understand more of a very important archaeological site in the form of Great Zimbabwe. So hopefully we can have a chat again at some point. Hopefully we see you soon, whether it's this side or your side, whatever it might be. But thanks for joining us, and keep well.
Thank you too. Thank you so much. Thank you for inviting me to this platform. I also enjoyed being here, the conversation that we had.
Thanks, Joseph.